Good morning, YouTube. The moment you've been waiting for is finally here. We are going to start working on the 1987 Ferrari Testarossa Majors. That means we're going to pull the engine out, take care of all the problems that it currently has, which admittedly is not crazy, but is regular maintenance for these cars. So believe it or not, every 5 years or so, you're supposed to pull the engine out, replace the timing belts, and any sort of other problems it may be experiencing, pulleys, tensioners, bearings and stuff, all those sorts of things get replaced if necessary. So we don't know exactly what condition it is because we don't have a paper trail. So as far as we know, this thing could be in great shape or could be in terrible shape. We just don't know. So we're going to assume the worst. It has been about 4.5 years or so since its last major. It's basically due for it. So we're going to get wrenching on it. But before we do, we're going to do all the computer stuff. So these old cars don't have OBD computers. You can't just plug it in. So Josh has a breakout box. We're going to be able to check on all the condition of all the sensors and computers and whatever in this thing, make sure it's in good shape. That way we know what we're getting into before we even start turning a wrench. So you guys are gonna like this. It's gonna be a huge series, so stay tuned. It's gonna be awesome.
Can't stop, won't stop. I can't stop, won't stop. I can't stop, won't stop. Can't stop.
So are you recording all of the nefarious activities?
So yes, this entire Ferrari Testarossa series is sponsored by Ricambio America. Go visit ricambioamerica.com, use the code NGS10 and you'll get 10% off your entire order. They supply parts for Maseratis and Ferraris. Great customer service, amazing place. I've been pretty much buying all of my Ferrari parts from them since I got my Ferrari, so you guys will love them. They're awesome. Hopefully you guys appreciate this, but we're stepping up our game, so I actually bought that lift and all these lights and made it so that now we can have a bit more of a higher quality production level. We're in the other side of Josh's shop, so yeah, there's a bunch of cars stored here and stuff, and put in a second lift there. So this Ferrari is going to be on this lift here in the corner. This will be my home for the next few months. All right, Josh, tell me about step 0.
Step 0 is making sure we understand what we're fixing before we whip the motor out of the car, unlike in Timmy's half-ass DIY 348 major service. So for about 10 minutes, Tim's been over here trying to get the second one
It
off.
was actually worse than that.
In order to do so, obviously Dan already started with a quick dyno pulse, so we know that at least at wide open throttle we've got a pretty good AFR and good engine power numbers, so we know that we don't have a significantly hurt engine. Visually looking at it, we can tell that, there's a lot of age on it and it's probably had minimum care. Unlike the half-fast, this is how you do belt services with no resources we did last time. This time we're gonna do slightly more professional. What we will start with today is factory diagnostic sheets. What a factory diagnostic sheet allows us to do is interrogate the sensors for the fuel injection system and the sensors for the electronic ignition system with a factory breakout box, which
nice.
patches between the computer and the wiring harness, so I can easily plug in my multimeter without having to get the wiring diagram out and back probe everything manually, which will take a lot of time. Within a couple of hours, we'll have a really accurate idea of what we're looking at.
So basically we got instruction sheet.
Yep, so here, instead of it being ECU pins, these pin numbers correlate to the pin numbers on the box.
Nice.
Because the connectors are already set up, to match the factory connectors on the control units and the wiring harness.
Since there's 2 computers, do we have to do it twice or you just do it once?
Yeah, we're gonna go through and check everything because you have,
One could be one bank and the other's the other bank.
It is. That's 2 4-cylinder engines. This is 2 6-cylinder engines. If you notice up here, we have 2 fuel distribution units.
Oh yeah, okay, up there.
Yep. You have 2 distributor caps.
Yep.
So it's 2 6-cylinder motors. So we have
Yeah, and
2
you can
units.
see 2 ECU plugs right there.
Yep.
Okay.
Yeah, and then the ignition control units all over there.
Okay.
Yep.
So it doesn't go through the firewall, unlike the 348. The 348, the ECUs were behind the rear seats, and the wires went through the wall. So that's nice. At least we don't have to do that.
Yep. The other reason why we're doing this before we tear the motor out is some of these tests are done with just the key on, so the control units have power. And some of them are done with the engine cranking. What's also neat about this is it gives us a couple of sensor graphs, but it also gives you a quick snapshot from the wiring diagram of the engine control system for quick reference along with the legend.
Could you imagine being the poor bastard that drew that up?
I can't imagine, because every time I use one of these, I lay it on the bench and I sit there with a straight edge and a box of colored Sharpies and mark out the circuit that I'm diagnosing to separate it from all the other lines. So yes, I can imagine how tedious this was, and I'm glad I didn't have to do it. The other thing that's cool is because the European cars didn't get catalytic converters and emissions regulations, so we have KE Jetronic, and then we have KE Jetronic with oxygen sensor. Since our car is an American car with oxygen sensors, we will be doing the test including the oxygen sensors.
Okay. I didn't put it in gear or anything, so it will roll if we...
Good.
So that comes out. That goes in.
This is going to take no time at all, and it's extremely accurate, whereas getting out the wiring diagram and opening up the connectors and back pinning, yeah, you can do it and it works, but it's inefficient and it's a pain in the ass. So the other thing that's cool, right, is the thing about diagnostics is just like everybody thinks an OBD2 scan tool is just this magic wand that tells you how to fix your car. All that unit does for the most part is relay information. It gives you a fault code, which is pre-programmed into the computer, right? Which is triggered when a certain conditions occurs. That doesn't tell you really what's bad most of the time. That just tells you the conditions under which it saw something outside of parameter. You still need to go in and interrogate and figure out which came first, the chicken or the egg. What's really great is not only does it tell us what pins we're gonna connect to, it tells me what scale I'm gonna be using on the DVOM. Port note, which is key off, ECU disconnected. It tells me what we're gonna be checked. It also tells me correct theoretical value. You'll notice for everything here, there is a correct theoretical value, even if it's a range.
Yeah.
So we can make some assumptions, but things like temperature sensors, you have negative thermal coefficient, you have positive thermal coefficient, and then you have a wide variety of ranges in which those sensors are designed to operate depending on the car. So you can't make a guess. This legend here that tells me what I'm testing and what my good range and bad range is pretty critical for me.
So the first one is pins 10 and 12, and it's set to ohms.
Yeah. The other thing too is it actually says key off and ECU disconnected. So,
so you don't even plug it into the ECU?
yeah, in this case, I'm gonna follow its instructions literally and take that lead off. So now we're just on the wiring harness and we're literally just testing the resistance.
On the sensor, not the computer. Okay, gotcha.
So our first step here, electro pressure actuator resistance. This component here is, there's a little black box on the side of the fuel distributor here. That is basically a electromechanical fuel pressure regulating device. So that unit right there trims the fuel pressure through the RPM and load range to make sure that the air-fuel ratio is always correct. Those units do go bad over time, and if it is bad, then your engine performance is going to really suffer. We've already driven this car and it runs pretty good, so I think those are within range.
We'll find out.
Yeah, it's easy enough to test, so we're going to verify for certain. We'll go 10, we'll go 12. So ohms, theoretical value is going to be 20, so the 200 scale should be adequate.
19.5.
There you go.
Pretty damn close.
Yep. So that one's good. This one here, coolant temperature sensor. So this is one we're talking about, right? Depending on the temperature, it's going to have a different reading.
Yeah, okay.
Right? And this tells us this is a negative thermal coefficient, right? Which means, as you see here, as the temperature increases, the resistance drops.
Huh.
We can assume, because the car's been sitting overnight, that the coolant's going to be approximately
Yeah.
temperature, which is about 72 degrees.
Yeah, we're looking at, that's our current temperature, so that's what we can kind of assume it is.
Yep. And so it says at 15 to 30 degrees Celsius, we're going to be in the 1.3 to 3.6 K ohm window.
221.
So there's that. And we're going to have to go to the 20K range. We're at 2.65.
Which is right in the middle.
I'd say that's pretty acceptable. Now we've got the throttle position micro switch. We check it in two positions, idle and as soon as it's open. Because at idle, it makes no contact. You open the throttle, the switch comes
But
in.
without the car actually running?
Correct.
Okay.
Yeah,
Yeah, because it says ECU disconnected, so we can't.
We're just testing the internal resistance.
Gotcha. So
through
we're checking the
sensors.
switch, make sure it works on and off, basically.
Make sure it's not shorted out or doesn't have excessive resistance. So
Okay.
when we crack it open, it should have about 140 ohms. And if it has way more than that, then we know that we have excessive resistance in the contacts
Cool.
and we need to replace it. Pins 1, pins 13. Okay, and we're gonna go down to the 200 scale because we shouldn't see more. All right,
That's a little.
we got a little resistance, so it probably wouldn't hurt to,
Replace that.
yep.
All right, so you're gonna hit the gas.
Yep, ready?
Yep. It went to 143,
Okay.
and it says should be 140.
Yeah,
Pretty close.
Yeah, if we can get one easily enough and inexpensively enough, it'll probably be worth doing because we do have a little resistance here at rest.
Yeah.
So it's not in perfect condition.
But it's not terrible.
No, it's acceptable, you know? I wouldn't have a problem with keeping that switch in there. Like I say, if it's going to be a, very expensive part,
Right, yeah, if it's a $10 part, let's do it. If it's a $200 part, leave it.
pretty much.
Yeah.
Resistance should be infinite and become 0 with throttle opening over 60 degrees of rotation. We're just going to make an assumption on our 60 degrees of rotation. So 5,
Infinite. And it's near 0. It's like 0.8, 0.7.
Okay.
It was pretty consistent that there was 0.7 and 0.7.
Yep.
All right.
Okay, so now this is an internal resistance of the O2 sensors. I personally don't really give a shit about the O2 sensors in this car. And here's why. Unlike modern EFI cars, the only thing the O2 sensors do in the CIS system here is trim fuel mixture at idle and part throttle conditions. Otherwise, the system defaults to a pre-programmed map that doesn't change. And that's for emissions work. So a lot of the rough idle and the hunting around and things that these motors do is because the fuel system is chasing that O2 sensor signal. And actually, when we base set the CO in the two distributors to make sure the fuel system is tuned and balanced properly, you actually have to do it with the O2 sensors disconnected, so that way you're not getting the electrical override. So the fact of the matter is, on these cars you can disconnect the O2 sensors and run it without it, and they actually run quite a lot better. And since we'll be doing some things with this car, which include not worrying about catalytic converters, because these cars were, intended to not run with cats, and the car's old enough that it's not critical to pass emissions here in most of the states, we're going to disconnect them and do away with them. So O2 sensor diagnosis is, always an issue with any car that has O2 sensors. It's complicated enough, and there's enough different types of sensors. The average person doesn't know a whole lot about diagnosing them. We have a really quick and easy check,
Okay.
which is simple internal resistance of the O2 sensor. Changes greatly with temperature, right?
Yeah.
So anywhere from over 1 million ohms of resistance cold to only 300 to 1500 ohms of resistance warm.
Gotcha.
Obviously ours are absolutely cold,
Yep.
so that's the result that we're going to be looking for here. I'm going to go to the 2 million scale, pin 7 and pin 8. That's 2K, 20K, 200K, 2 million, 20 million. So this tells me that
It's greater than a million.
our O2 sensors are already shit, because I see that they're plugged in, but we have no values. That's fine. We know that now, and we don't care.
All right.
So now this one is still ECU disconnected, but then we're going to do a key on and crank for a few seconds. And this is voltage signal to ECU from starter motor. Range is 8 volts to 13 volts. Make sure that we have initial battery power, and then we're going to make sure that during cranking we're not dropping below 8 volts, because below 8 volts the computer doesn't have enough power to work properly.
Okay. Got up to 9.
Okay. So battery might be a little low.
The next one's 2 and 21. Same thing, crank.
And this is ECU to K terminal of coil during at cranking speed.
0.2 volt.
Yeah, 3 to 4 peak.
3 to 4 peak. Okay, still at the same range then.
Yep.
Negative 0.68.
So that one was 1 and 6. So then we got 1 and 13, right?
Yeah. So was that one's all right?
Yep.
Okay.
Yeah, because it said 0.2, approximately 0.2 with a 3 to 4 volt peak, so 0.68 is,
Fine.
yeah.
Okay.
So now we're doing 1 and 13. Voltage supply
to
from
ECU.
protection relay.
Okay.
So that should be
8 to 13.
Right?
Yep. 0. So it should be reading now.
Should be.
Yeah, we got nothing. Uh-oh. Uh-oh.
Alright.
Got a problem.
Yep, we got something going on with the protection relay. We'll double check on the other connector on that one and just make sure that it's not something goofy where we
Yeah.
only,
Looks like it's only on one side or something.
yeah.
I mean, it flinched briefly to negative 0.02, but that's it.
Okay, so we may have a protection relay concern. So now pins 14 and 18, 20 volt scale.
7 to 8. Okay,
All right.
ECU barometric capsule, and
Uh-huh.
airflow sensor potentometer.
Uh-huh. Now it wants us to go ahead and,
Oh, now we've actually plugged in.
yep.
Okay.
Now we're gonna connect to,
Important. Turn key off, connect the ECU, then turn key on. Okay, we should
yeah,
see if
because we basically just connected the wiring harness to the ECU, and you never want to do that in any
Oh,
car with the key
power
on.
Yeah,
Yep.
okay. See figure 2. Oh, okay. Oh, it depends on the barometric pressure.
Uh-huh. See? Figure 2.
I don't know what barometric pressure is out today, but
Me either. We could look it up if we cared, but really we're just going to look and see
it's
if
somewhere between
it's-
1.6 and 4.8.
Yeah, exactly.
1.44. 1417 is voltage output from airflow sensor potentometer should be 0 at rest position, increase progressively to between 7 and 8 volts with complete opening.
Yep. So we got 0 volts.
What's the airflow sensor plate?
That is the metal flap inside here that actually controls your fuel flow. That gets into a whole theory discussion on how CIS actually works, which I don't
we
feel like
open
doing
that?
right now, so we'll talk about that later.
Sure. How do we open it?
Don't worry about it, watch it.
Okay, I'll watch. It just flinched to 0.01. Yeah. What's a 0.38 or so? Alright, so we're pulling off the air box so we can get access to these things. So you do those?
Nope.
No? Oh.
Nope. We're gonna take these, and then under here and under here. But what you can work on
Oh,
is
those.
these, and that.
Okay. Alright. Oh, get the hose. Alright, got that box out. Oh, those. Wow. Alright. Oh, then we manually push it. It started to move.
All right, so we probably need to address that.
Alright, so that one's bad.
Yep. So now, this test here is coolant temperature sensor, negative temperature coefficient, to the pressure actuator with cold resistance. So it's saying it should be 1500 to 2500 millivolts with the connector disconnected. Remember, right? It's this one here. ECU
Alright.
connected, key on, connector removed, plus crank the engine, right? And voltage should increase. So it should increases until exceeding 300 millivolts and then decreases slowly to a value of step 12.
Which
Okay.
was nothing.
Uh-huh.
Well, if it's already broken, it's probably not going to show anything. But,
Probably, but we're gonna go step by step anyway.
okay. Yep. Well, it went, and then, hold on. It went off the scale.
Okay.
Try again. Negative 3 point something. Which 300 millivolt should be... Oh, it way exceeded 300 millivolt. It went to 3 volts. Because I changed it to the 20 volt scale, and it went to 3 point something.
And now we're gonna bridge pins 2 and 21 to simulate a warm engine. But we already know that we have NTC issues. We've done 2 other tests,
Yeah.
and it's not satisfactory.
So
Okay?
whatever, we'll just know we gotta replace that
Uh-huh.
sensor.
And then
Okay?
this one here is another one. This is a voltage current.
Same sensor.
Mm-hmm. Well, same circuit,
Oh, okay.
because it's with this sensor disconnected.
Oh, okay. Well, there we go. Went through all the steps. And of everything we tested, there's only 3 issues so far. So we got the throttle micro switch is starting to go, but it's probably okay. The airflow sensor potentometer and the coolant sensor for pressure actuator. Well, that was kind of handy.
Yep. See, so now we know for sure we got to replace the coolant temp sensors and evaluate that circuit a little bit further and make sure we don't have any other electrical problems in that circuit.
Well, there you have it. We tested all the sensors, and we know 3 sensors are kind of questionable. One of them's definitely bad. One of them's kind of questionable, and the other one's kind of on the fence too. So we'll probably just replace them all, assuming they're cheap. But that's a great way to kick this whole thing off. So the next video, we're gonna start actually ripping this engine out. So you guys are gonna want to stay tuned to that. Don't forget, go visit RecanviAmerica.com. Use the code NGS10 to get 10% off your entire order. They've been badass. They've been hooking us up, and they're gonna continue to hook us up with this entire Testarossa project. You guys are gonna want to stay tuned. It's gonna be sweet.
Wanna know what I'm into? We can start with a blindfold. You know the love goes deep, baby. Tell me what you in for. I'm over the hill and under the brakes, over the pain and under the faith, over the past, I wash it away. Tell me if you looking to stay, yeah. Now we can get it in through the daytime, or we can find the moon in the stateside. I know you got dreams, we could